Alright guys, so here is a quick review video for the test on moving straight ahead investigations 1 and 2 on Friday. Okay, so y equals mx plus b, an important equation for this test, so remember y is our dependent variable, not always y, m the rate of change, x the independent variable, again not always x, and then b the y-intercept, which you write as an ordered pair. Okay, so when x is 0, y will be b. So I threw the vocabulary words on here. I'm not going to go through and read all of them to you. You can pause and look, but these vocabulary words you should know for this test. So we have linear relationship. We've been talking about this all unit so far, a relationship in which there is a constant rate of change between two variables. So we talked about it as x increases by 1, y increases or decreases by a constant amount. We have our dependent variable, right, the value that depends on or is determined by the other, which is the independent variable. All right, just remember that we graph the dependent variable on the y-axis. Okay, independent variable determines the dependent variable graphed on the x. So x, y, independent, dependent. The x-intercept, the point or the spot where the line crosses the x-axis. So it's going to be an ordered pair. You have some number, and then y will be 0. Y-intercept, the point where the graph crosses the y-axis. So write this as an ordered pair. Don't just write the value of b. We talked about this a little bit. Okay. So the point where the graph crosses the y-axis. Okay. So when x is 0, y will be b. And you see that in our equation, y equals mx plus b. We talked about the coefficient. That's the rate of change. So that's our m in y equals mx plus b. And then solutions, ordered pairs. Okay, they make the equation true when substituted in. They're on the graph of the line. They're in the table. All right, so I threw these focus questions up here. None of these should surprise you. Some of them get a little bit repetitive. The first one, what equation represents the relationship between the time and the distance you walk at a constant rate from investigation 1.1? What are the dependent and independent variables? Well, distance equals rate times time, where distance, our walking rate, is our dependent variable, okay? R is our walking rate, and then T, time walked, independent variable. So this would be like y equals mx plus b, but b is 0. So essentially just y equals mx. How can you predict whether a relationship is linear from a table, a graph, or an equation that represents the relationship? Well, we look in the table as the independent variable increases by 1, the dependent variable increases or decreases by a constant amount. So you're going to see a constant difference in consecutive rows where x increases by 1. That difference can be positive or negative, okay? The graph will be a straight line. The equation will be in the form y equals mx plus b, where m or b can be 0. If m 0, you have y equals b. If b is 0, you get y equals mx, okay? This will be a straight line. This will go through 0, 0. 1.3, what is the pattern of change in a linear relationship? Okay, getting repetitive, but as the independent variable increases by 1, the dependent variable increases or decreases by a constant amount. 1.4, how can you determine if a linear relationship is increasing or decreasing? Well, if you look in the table, as x increases by 1, y will be increasing by a constant amount for increasing, okay? The graph is going to look like this here. So as you go from left to right, the graph is increasing from left to right, okay? Equation, the m and y equals mx plus b is positive. For decreasing, as x increases by 1, y decreases by a constant amount, the graph, as you go from left to right, will be decreasing, okay? The equation, the m and the y equal mx plus b is negative. 2.1, when is it helpful to use a graph or a table to solve a problem? Well, we looked at graphs, and if you can't read the exact answers off a graph, which we know is not always the case, it might be more helpful to use a table. Okay, remember, you could also use the equation. 2.2, how does a pattern of change for a linear relationship appear in a table or graph or an equation? Okay, you can read this. I'm not going to read this one, okay? The only thing I want to note out is for the graph, we talk about the higher the absolute value, the rate of change. So if it's positive, it's just the higher the number, the steeper the line. If it's negative, it's higher the absolute value. 2, 3, how can you decide if a table or an equation represents a linear relationship? Table, look for as the independent variable increases by 1, what the dependent variable increases or decreases by. It has to be constant. In an equation, again, y equals mx plus b, where m or b can be 0. Last investigation on the test, 2.4, how are solutions of an equation of the form y equals b plus mx related to the graph and the table for the same relationship? Well, we know the solutions of an equation y equals mx plus b are ordered pairs. Okay, so that's xy. Remember, it's not always xy, so think of it as independent variable, dependent variable. Okay, that make the equation true when substituted in. In a graph, if you trace to the x value and go up to the line, you'll reach the corresponding y value. So if this is our graph and this is our line, this will be x, trace up, go over, this is y, this is the ordered pair x, y. If you trace up to the y value, so going this way and then over, okay, and then down, you'll get the corresponding x, which belongs to the y. In a table, the solutions x, y show up in the same row. So the review packet, you should make sure that you know how to do every problem in it. I'll go through some of them here. I also picked out some pretty important homework problems. It wouldn't hurt at you to look at these again. So review packet, a ride in a cab costs 40 cents plus 15 cents per mile. So we want to write and graph an equation. So we have y equals 0.15x plus 0.4. So y is going to be our cost, 0.15 is our rate, 15 cents per mile, x is our number of miles, 0.4 is our flat fee to ride a cab, 40 cents. So if the cab charges 70 cents for a ride, how many miles? Well, 70 cents corresponds to the y value because it's total cost. So we want to plug in or substitute in 0.7 for y. So it would be down here. Y equals 0.15x plus 0.4. 0.7 equals 0.15x plus 0.4. Subtract the 0.4 from both sides. Dividing both sides by 0.15 gives us x equals 2. Okay, we need to contextualize all these problems. So it's not good enough to just say the answer is 2. Okay, how many miles do you get? You get 2 miles. See, how much does a cab charge for a trip of 8 miles? Here we are substituting 8 in for x. So y equals 0.15 multiplied by 8 plus 0.4. Y equals 1.2 plus 0.4, or y equals 1.6. So the answer, $1.60. To graph this, there's a bunch of different ways you can go about graphing. So this equation is in the form y equals mx plus b, so we know the y-intercept right away. Okay, that's 0 comma b, or 0 comma 0.4. So we can throw that point on right away. Now you just need any other point, or you can use the rate of change to find another. So as x increases by 1, y increases by 0.15. That's a pretty small rate of change, so I'm going to use one of the points that we found from these equations, or from part B and C. So if you look here, the ordered pair that corresponds is x is 8, y is 1.6. So that's the solution to the equation. We know it's on the graph. I'm going to go over to 8 and 1.6 on the graph. All right, so now we just need to connect these. All right. And I missed a little bit there, but can fix that. All right, looks a little better. 5, I'm going to use the graph of the 3 lines to complete that table over there. So, oops. A, what is the constant rate of change? Well, if we look at A, we can look right here. As x increases by 1, that's this direction, y decreases by 1. Okay? As x increases by 1, y decreases by 1. So we can say the rate of change for A is -1. The y-intercept for A, all right, so this is the x. It's a little hard to see here. So the y-intercept, put that in another color, 1, 2, 3, right here. So that's going to be, as an ordered pair, 0, 3. The x-intercept, right here, 3, 0. All right, B was the rate of change. Well, if we look at this point here, as x increases by 1, y increases by 1. As x increases by 1 again, y increases by 1 again. So we can say the rate of change is +1. We need the y-intercept, which is right here, and that's going to be the point 0, 2. X-intercept, oops, sorry, I just did the x-intercept. So the y-intercept's here, and that's 0, 2. The y, or the x-intercept here, -2, 0. All right, my apologies. So then C, let's get another color. The rate of change for C, well, if we pick this point here, when x increases by 1, y increases by 2. Okay, so we can say the rate of change is 2. The y-intercept for C is right down here. Okay, so that's 1, 2, 3, 4. So when x is 0, y is -4. Y-intercept right here, go over 2, so x is 2, y is 0. So now we need to match these equations. So A is y equals 3 minus x because the rate of change is -1. The y-intercept is 3. Let's see, B is y equals 2 plus x. This is our B. 1 is m. Then finally C, y equals -4 plus 2x. B is -4. M is 2. 4, okay, we want to graph this. So again, a couple different ways. We can pull the y-intercept right out of this equation. So B is -1. So our y-intercept is 0, -1. Okay, so that's going right here. So our rate of change is -3. So we can say as x increases by 1, y decreases by 3, or we can pick any other point. I picked the point -2, 5, because when y is 5, right, we get -3x minus 1, 6 equals -3x, x equals -2. So if I go to the point -2, 5, all right, and then I connect them. Okay, so just remember, you need 2 points to graph a line. The y-intercept is usually a pretty good one. You can count. So if we wanted to check this, let's get a pen. Go up 1, 2, 3, and then over 1. Okay, so that shows that the rate of change is -3 as x decreases by 1. Oops, sorry, as x increases by 1, y decreases by -3. All right, so we want to write an equation for the line. Alright guys, part 2 of this video, we want to write the equation from the given graph. So we know it's going to be in the form y equals mx plus b. We need to find both b and m. So if we go up to the y-axis where the line crosses, we see that it's right here. And that point is 0, 2, so we know that b equals 2. Now we want to find 2 points that we know the ordered pair for. So I'm going to stick with the y-axis here and then pick this one down here. And we need to see the rate of change between the two. So if we go down and connect these points, right, we see that as x is changing by 4, y is decreasing by 5. So y is changing by -5. So our m is going to be -5/4. Or -1.25. So our equation becomes y equals -1.25 x plus 2. Alright, another example of writing an equation from the graph. So you have y equals mx plus b again. To find b, find where the line crosses the y. That's going to be this point right here, which has the ordered pair 0, -4. Now we need to find m again. So if we pick 2 points, we can pick these two right here, and then connect them in the triangle like we did last time. So as x increases by 1, we see y here is increasing by 2. Okay, so m is going to be 2/1, or just 2. So the equation becomes y equals 2x minus 4. Alright, so looking at a table, you need to be able to look at a table, decide if it's linear, be able to explain why or why not, describe the rate of change, find the y-intercept, write an equation from a table that is linear, and be able to make and recognize a graph from that table. So looking at an example, right, so x, how are the values changing? Well, we can look at the difference in the rows. So here we have a +2. On the y, it's decreasing, so 18 to 6 decreasing by 12, 6 to -6 decreasing by 12, and then finally decreasing by 12 again. So we can say this is linear, and then we want to say why. So to find the rate of change, we want to find how y changes as x increases by 1, not 2. So dividing -12 by 2 gives us -6. So we can say as x is increasing by 1, y is decreasing by -6. Okay, so that describes our rate of change too. So why is it linear? It has a constant decrease. Okay, and that constant decrease is in the dependent variable y as x increases by 1. So what are the coordinates of the y-intercept? We know x needs to be 0. We see that we don't have 0 in the table, but we know that it's going to be right here. And that's halfway between -1 and 1. We also know as x increases by 1, y is decreasing by decreasing by 6. So we want to take this point here, -1, 6. Right? Increase x by 1 to get 0, decrease y by 6 to get 0. So the coordinates of our y-intercept are 0, 0. So our equation, y equals mx plus b, well, b is 0, so it's going to be y equals mx, which will be -6x. So if we were going to graph this, we can use 0, 0 as our starting point, and then you can pick any other point on this table and connect. Second table, again, we want to find out if it's linear or not, so look at the change in x. So we have +4, then going up by 2, going up by 13, and then going up by 1. Right, over on the y side, +13, +3, +31, +4. So if we look at how X changes and how Y changes, in the first row, we have 13 over 4, which is about 3.25. The second row, 3 over 2 is 1.5. So right here, we can say that it's not linear. Okay, so Y, there is no constant rate of change. Okay, so even if these two were the same here, you need to make sure it's the same between every row. Okay, going down, you can see that it is not. All right, last one like this. X goes up by 2. Y is going up by 6. So is this linear? Yes. Why? As X increases by 1, we're going to see that Y increases by 6 over 2 or 3. So that's also describing our rate of change. So it's linear because as X increases by 1, the dependent variable increases by a constant amount. So M will be 3. We just need to find B to get an equation. Okay, so again, we can look in the middle of that point there between -1 and 1. So instead of increasing by 6, we want to increase by 3. So -11 plus 3 gives us a -8. So our y-intercept is at 0, -8. So B is -8. The equation becomes y equals 3x minus 8. Okay, if you were to graph this, good starting point would be the y-intercept, 0, -8, and then you can pick any point on this table and connect. All right, so other things that you need to be able to do, given a representation of a linear relationship, either a graph, a table, or an equation, know what the other two relationships will look like. So given a graph, okay, how can you pick out what the equation would look like, what the table would look like? Same for the table, how could you pick out what a graph would look like, what the equation would be? And then finally, given an equation, how could you figure out what the graph would look like, what the table would look like? All right, and then I want to just go through a couple homework problems that I think would help for this test. So from ACE number 2 to number 8, you have two companies to print brochures for the walkathon. Company A represented by this equation, company B by this one. So A, for what number of brochures are the costs the same? So we talked about a couple different methods to do this. One of them was setting the equations equal to each other. All right, so if we do that, we want to set company A, 15 plus 0.1 multiplied by n, equal to the cost for company B. All right, so then n equals 100. So for 100 brochures, the cost will be the same. All right, and then you could check that by plugging this back into both equations. So for company A, we have cost equals 15 plus 0.1 times 100, which is 15 plus 10, all right, which is 25. For B, you'll get 0.25 times 100, which is again 25. So for $25 for both companies, they'll get 100 brochures. So B, if they only have $65 to spend, how many brochures can they print? Well, if they use company A, you want to substitute in 65 for C. So doing that. All right, so solving for n, we get 500. So for company A, they will get 500 brochures if they spent $65. For company B, substituting in 65 and for C, we get 260. So for $65, company B can only have 260 brochures. All right, so what information does the y-intercept of this graph represent for each equation? Well, for company A, the y-intercept is 15. So that tells us that they're going to have a $15 initial cost. So even if they don't print any brochures, it costs them $15. Company B, the y-intercept, can be represented by a plus 0, and that says there's no initial cost for using company B. All right, so what information does the coefficient of n represent in each equation? For company A, the coefficient is 0.1, and that tells us that each brochure costs 10 cents to print. Company B, the coefficient is 0.25, so that tells us that it costs 25 cents to print each brochure. Okay, so finally, for each company, describe the change in the cost as the number of brochures increases by 1. So, for A, as n increases by 1, the cost increases by 10 cents. For company B, as n increases by 1, the cost increases by 25 cents. Okay? Number 9, it talked about 3 different DJ companies and a school committee had to pick one. So we get quotes for their costs. So Tom, $60 per hour. Sabina has a $100 setup fee plus $40 per hour. Then DJ Derek, $175 setup fee plus $30 an hour. So we want to get equations for each of these. Okay, so Tom's just $60 per hour. Well, let's say cost is going to be then 60x, where x is the number of hours. Sabina, well, hers cost, it's going to be 40x, but she also has a $100 setup fee, so plus 100. Finally, for Derek, we're going to have cost equals 30x, but then a $175 setup fee, so that can be plus 175. So what information does the coefficient represent for each DJ? Well, for Tom, it's $60 per hour, so it's the DJ's hourly rate. For Sabina, it's $40 per hour, so her hourly rate. And then finally, Derek, this is $30 per hour, so we can summarize all that by saying that it's each specific DJ's hourly rate. For C, for each DJ, what information does the y-intercept of the graph represent? Well, for Tom, the equation C equals 60x, the y-intercept would be plus 0, so we can say no initial fee or deposit. For Sabina, we have plus 100, so we can say that she charges a deposit of $100, or there is a $100 initial charge. And then for Derek, plus 175. Okay, so there is a $175 deposit, or he charges just a flat $175 fee to start. So D, suppose the DJ will need to work 8.5 hours. What is the cost of each DJ? For this, you need to substitute 8.5 into the equations for X, because X is hours. So for Tom, we get C equals 60 multiplied by 8.5, which is $510. For Sabina, solving that, we get $440. And then finally for Derek, we get cost is 30 times 8.5 plus 175. Solving gives us $430. So suppose the committee has only $450. How much could each DJ play? Well, now 450 needs to be substituted in for C, because we're talking about total cost. So Tom, 450 equals 60x. Solving gives x equals 7.5, so they get 7.5 hours. Sabina, 450 equals 40x plus 100. If you were to solve that, you're going to get 8.75 hours. Finally, Derek, make some more room here. All right, 450 equals 30x plus 175. Solving gives us 9.16 repeating for x, so we can round that and we can say about 9.12 hours. So when you're going through these problems, you need to make sure that you're not just answering the number, but you're answering the question. So make sure we include our units, make sure we know what the variables mean, make sure we can contextualize the problem. So it's not just always going to be a flat fee. For here, it is, a deposit or a flat charge. You need to read the problem and see what it's asking you. Finally, just quickly, a graphing calculator review. I'm going to go through these slides. You can pause and look in more detail. So this is the example from Emile and Henri's walking race, 2.1. To get a table, you go to y equals, and you need to put in both equations. You can change the table settings hitting second window. So what we wanted to start at, what we wanted to skip by. Then second graph gives you the table. Okay, if you're looking for the intersection point, you would look to see where both dependent variables were the same. For this specific problem, it was x was 30, y's were both 75. You could graph these. So remember, it's not good enough to just graph. You most likely need to change the window setting. So you have these in y equals. Window button gives you this window setting, okay? So it's not just a set window setting every time. You have to look and think about how far do you need the x values to go over, how far do you need the y values to go up. Hit graph, and it'll spit you out a graph. We can use this graph to calculate the intersection pretty easily, so this is going to be a really nice check. So I don't recommend just doing it this way. You can, but if you solve these intersection problems by hand, check on the calculator, you're going to know 100% if you got it right. So second trace brings up the calculate menu, all right? And that's after you're already in the graph window. 5 is intersect. Make sure you're close to this point, and then hit enter 3 times, and it'll give you the exact coordinates of the intersection point. Something else that you could do is trace. So if we look here, it's not always going to give you nice numbers, but you can trace, get pretty close. Sometimes it will spit out exact values. One other function, and we only talked about it briefly, is this, a value. So if you're on any graph and you hit the value function, it'll ask you to enter a value for x, and then it'll give you the corresponding y value. So just a bunch of different options that you can use with the graphing calculator. Okay? If you have any questions, comments, or concerns about the test, please shoot me an email.